In this video, we're going to do some guided exam question practice on the 2019 Junior Cert Science question 11 on boiling points. Now, this is the first of the 30-mark questions in this paper. So 30 marks means about 10 minutes. And I would imagine that we can typically expect to see at least one of these types of questions on the exam. Yes, the general question was about boiling points, but there's an underlying theme here, and that is it's a type of question that asks us about how to design and properly do an experiment. This is typically something that students sometimes find difficult. So do bear with me while we look at this type of question, because I do think that they're a really important type of question, and we'll definitely see something like this on your exam. So let's start reading. Set your timer for 10 minutes and we'll get cracking on it. It says, okay, so timer started. It says sodium chloride, which is table salt, is a white crystalline solid. This is it here. That's what it looks like. Okay, and it says water is a solvent and it has a boiling point of 100 degrees. Sodium chloride can dissolve in water. So we say that sodium chloride is a soluble substance. So there is some information there in that bit of text. Not sure whether we're going to need it yet or not, but I've underlined what I think are some of the important words. You can do the same if you've got exam papers. Let's get into what it's asking us to do. It says a student was asked to investigate. So we're doing an investigation. What effect? Okay, so we're investigating some kind of an effect. That's what we usually do in experiments. What effect does adding salt have on, now we're measuring the effect of something on something else. This is really important. This is why I'm highlighting these words in different colors. The student was asked to investigate what effect adding salt has on the boiling point of water. Okay, I'm going to help you do something here. When you're given a sentence like this, it's really important when we're talking about an experiment that you learn to look at the sentence of what we're trying to do and figure out what the variables are in the question. Now, I've explained variables to you guys lots of times. Okay, a variable is anything that can change in an experiment. So the word variable means thing that can change. Okay, so what are the variables? What are the things that can change here? Well, the things that can change here is adding salt. We can add no salt, we could add 2 grams of salt, we could add 4 grams of salt. The amount of salt we've added, that's a variable. I can add none, I can add some, I can add a lot. Okay, so this here is what we would call variable 1. And it's a really important way to start thinking about these types of questions, is to try and identify the variables. So variable 1 is whether we add salt or not. And we're trying to measure the effect of variable 1 on variable 2. So what's variable 2? Well, variable 2 is the boiling point of water. Variable 2. Okay, so the boiling point of water, we want to see, does adding salt make the boiling point of water change? This is really important thing to be able to do, is look at something like this, pick out the variables. We've done this in class before, we've done this type of thing, so I'm hoping that this would be familiar to us. The next thing it says is to write. So we're asked to write, that's the action word, write a suitable hypothesis for this investigation. Okay, so what I'm going to do is I'm going to give you an opportunity, if you know what that means, to pause the video now and try and write a hypothesis for this investigation. Do that now. Okay, so you should only be playing if you knew how to do it and you paused it and you wrote it down. If you didn't know how to do it, I'm going to try and give you some help here. What is a hypothesis? A hypothesis is where you predict or guess what will happen in the experiment. Okay, so again, if you think you know what's going to happen, pause the video, write it down. Okay, so again, you should have tried to write a hypothesis. I'm going to give you a little bit more help now for anyone who really didn't know how to get started. Or I want you to look at your answer and see, have you done this? If not, you can improve your answer. Okay, your answer, your prediction should talk about variable 1 and variable 2. You should definitely be talking about them 2 things in your answer. So look at variable 1, look at variable 2, and look what we're asked to investigate, the effect of variable 1 on variable 2. So when you're making your prediction, you should say, I think that, talk about variable 1 and how it will affect variable 2. So again, pause the video. If you weren't sure, check your answer. Have you included variable 1 and variable 2 in your answer? If not, pause the video and rewrite it and make sure you include variable 1 and variable 2. Okay, Right, what kind of things should we have written here? Okay, well, we're going to be adding salt. So we're going to be starting at 0 salt probably and starting to add salt. So you might write something, you might begin the sentence like this. The more variable 1, whatever that is, the more I increase variable 1, the more salt added, ... So if you hadn't began it like this, you hadn't started talking about the salt, again, pause the video, finish this sentence off. Make sure you're talking about the salt and what comes next. Pause the video, finish it up. Okay, so hopefully you have now talked about the more salt added. Well, what's the effect going to be? Okay, so what are we going to say? The more salt added, well, I want to see, you're predicting how it's going to affect the boiling point of water. So there's two possibilities here. You could say the more salt added, the higher the boiling point of water. That might be something you said. The higher the boiling point of water. The alternative is the more salt added, the lower the boiling point of water. Maybe that's what you thought. Maybe you thought adding salt is going to decrease the boiling point. I'm not sure which one you predicted. Both of them are valid. Okay, both of them are okay, because we don't know yet. We haven't done the experiment, but they're both valid guesses. But if you don't talk about salt, adding salt, and how the boiling point of water is going to change, then it's not a valid hypothesis. So you should be going for one of those. Okay, notice what I've done here. I've talked about adding salt, the more salt added, sorry. So notice how I've included variable 1, and I've talked about how it's going to affect the boiling point of water, variable 2. That's really important. If you don't do that, your hypothesis is not going to be right. Okay, so that took a little bit longer than expected because there was quite a lot of revision in there. Okay, the next section, let's have a look. It says, what is meant by the boiling point of water? So pause the video. If you know this, write it down. Do that now. Okay, so if you didn't know it, I'm going to give you some help. Okay, so break down the two words. What does this bit mean? And what does this bit mean? So what does boiling mean? So think about that. What does that mean? Say it in your head. What is boiling? And what does the point bit refer to here? The boiling point. What kind of a thing is the point here? Again, so pause the video, put it down into a sentence now. What is boiling point? Okay, so hopefully you realize that in this case, the point means temperature, and boiling is when a liquid turns into a gas. So to put this into a sentence, it will be the temperature. The boiling point is the temperature that a liquid changes to a gas. So the temperature that a liquid changes to a gas, this is called the boiling point. Okay, hopefully most of you knew that one. Okay, so the next bit then, it says this laboratory instrument. Okay, so instrument just means like piece of equipment. So this laboratory piece of equipment is used to measure the mass of the salt, and it's shown in the photograph. So this piece of equipment here, how do we measure the mass of the salt? You're just asked to identify. So identify just means to name. Can you name this piece of equipment? So you either know this or you don't. I would expect you to know this by now. Pause the video and write it down now. All right, this here is called a mass balance. Okay, and I showed you where that word came from before in class. I showed you a really old style mass balance where they used to actually balance two masses. Okay, so it was like I'm not going to talk too much about it. It was used to balance masses, called a mass balance. All right, in the next bit, now we're starting to get into slightly more marks here. Okay, so this is quite this is what more marks. Remember, this question is what 30 marks, whereas the questions we've done before this were only what 15. So we're going to need more points here. Well, let's see what it says. In the space below, we're asked to draw. That's the action word, and it has to be a labeled diagram. Now, if it's not a labeled diagram, we're not going to get any marks. We're not going to get all the marks anyway. You could have a lovely diagram, but without labels, it's not worth all the marks that are going. It says here of the arrangement of the apparatus, so the equipment, so how the equipment is set up if we want to determine or find out the boiling point of water. How could we set up equipment to try and measure the boiling point of water? But the first thing I want you to think about here is, well, before we start drawing, let's make a little list of the equipment that you might need for this experiment. If we want to measure the boiling point of water, let's think about, let's make a little list. 3 things, please. Try and think of 3 things you would need here to measure the boiling point of water. Pause the video and write them down in the corner here like this. Okay, so showing me writing, if you've tried to name the equipment, I want you to do 3 pieces of equipment. I'm giving you some help here if you didn't get this already. The first thing I want you to think about is, okay, well, we need some water and we're going to be measuring it as we heat it. So the first thing we're going to need is a container for water. And we can't call it a container. What type of a container might we use in the lab to hold the water while we heat it? Pause the video, write that down. Okay, the second thing I want to think about is, okay, we're going to need to measure the boiling point, so we need to heat the water up. What method are we going to use for heating? How are we going to heat up the water? Pause the video, write down the answer. Okay, and lastly, how are we going to find out what temperature it boils at? What equipment are we going to use to measure the temperature? Okay, so here, here, and here, make sure you have the names of these 3 pieces of equipment written down. All right, so you should only be playing if you've written down the names of these 3 pieces of equipment. The container here, I would use the most sensible one. It's not the only one you could use, but the most sensible one would be just a general beaker. And we all know what a beaker looks like. You could use other things. You could use a conical flask. You could use what else could you use? A test tube maybe, or a boiling tube, but it wouldn't be the most suitable thing. A beaker is probably the most sensible piece of equipment there. For heating, you could use 2 things. My students will have used a thing called a hot plate. But other students may have in the past used a Bunsen burner, but then you're going to need loads of extra equipment. You're going to need a tripod stand and a gauze and stuff like that. So hot plates are handier, and that's what we use in our school. The next thing is, how do we measure the temperature? Well, we use a thermometer. Okay, so remember what the task was. It was to draw a labeled diagram of the equipment, the apparatus used to measure the boiling point of water. So the first thing we're going to need is to show how it was set up. So think about, okay, so I'm going to draw the hot plate first. That was one of the pieces of equipment I needed. So begin, I'm going to draw my hot plate. Again, it doesn't have to be a perfect diagram, but that's what labels are for. That lets the person who's reading the diagram know what it's supposed to mean. So that's a hot plate. Here is my beaker. So that's them 2 ticked off. The last thing is the thermometer. Now, I'm not measuring nothing, so I need to put something inside the beaker that I'm going to measure. Remember what it was? We were trying to find the boiling point of water. So I'm going to put the water into the beaker and label that as well. That's important. It's not equipment because it's a chemical, but it's still there. That's what we're trying to measure. And then the last thing, very simple thermometer. Don't go too overboard, spend too much time drawing it. Simple lines, guys. Thermometer. And I think that that is definitely enough of a diagram to get you all the marks there. Okay, so well done if you did something like that. All right, let's move on to the second part of the question. This was on a separate page. It said the students collected the following data for the boiling point of the solutions that were made when various masses of salt were dissolved in 60 centimeters cubed of water. So we've got different masses of salt in 60 cm cube portions of water, and then we've measured the boiling point for each solution. So as you can see here, we're starting at 0 grams of salt and working down to 8 grams of salt. Okay, and what I want you to do before we look at anything else, let's look, do we see any pattern? So mass of salt, as we go from 0 to 8 here, we can see that we're adding more salt. Okay, so we could say as we move down here, we're adding more salt. Over here, we see what happens to the boiling point for each mass of salt. So what's the general pattern that you see as we go down? So as we add more salt, so that's the most salt, that's the least salt. As we add more salt, what's happening to the boiling point? I want you to write down the side of your page or just scribble on the page there, write down what you would say is happening here. Okay, so I would say that the more salt, the higher the boiling point. So as we move down the table, the boiling point is getting higher. When there's 0 salt, it's 100.6. And when there's 8 grams of salt, it's 109.6. So the more salt, the higher the boiling point. That's the pattern. Now, what I would say is here I see straight away there's a blank space. So that's telling me I'm going to have to do something in there. So let's go ahead and read the instructions. What does it say? It says to calculate the average boiling point when 4 grams of salt was dissolved in 60 cm cubed of water. So for 4 grams of salt, that's up here. Here's the 4 grams of salt. And it says calculate the average boiling point. So here I've got 5 different readings that were taken. So the experiment was done 5 times and was done 5 times for all the temperatures, as you can see. But this one has not got the average worked out at the end. All the others do, and we have to find that. So I'm guessing most of you know how to find an average. So I want you to pause the video and work out the average here now. Do that now. Okay, the next thing is I'll give you a bit of help if you didn't know how to do this. To do an average, what we need to do is take our 5 readings. Because there are 5 of them, we're going to add up all the values and then divide your answer by 5. Okay, and that will give you an average. And a really important thing to remember is that averages, when we get them, so this here is an average, for example, 109.6. Averages are always somewhere between the biggest and the smallest reading. So for example here, for 8 grams, the biggest reading is 108. Sorry, the smallest reading is 108 degrees Celsius, and the highest reading is 111. Average should always be in between them. If it's way outside that, then you know you've done something wrong. Okay, so I want to pause the video and find the average. Okay, so the way this should be is 103 plus 105, the second reading, plus 104, the third reading, plus 106, plus 107. They're the 5 readings over 5, because there were 5 of them. That will give me the average. So I want you to get out your calculator, use your fraction button, do this on the top line, this top square of the fraction button, and then scroll down to the bottom square and put in 5, and then see what your answer is. Okay, so your correct answer here should be 105. So well done if you got that. 105 is the average here of these numbers. All right, the next one, it says, suggest a reason why the student repeated the investigation 5 times for each mass of salt. So you see here, for each mass, there are 1, 2, 3, 4, 5 readings. Okay, that's what we just did. We calculated an average for those 5 readings. So there are 5 for all of them. Suggest why it was done 5 times. Why is 1 time not enough? Okay, now, if you know the answer to that, I want you to pause the video and write down the answer now. All right, if you didn't know the answer, then I'm going to have to give you some help to try and figure it out. Okay, so why would it make sense to do it 5 times? Well, say, for example, that we take this one here, the number 2 grams of salt. Let's think about the boiling points here. The first time we measured it was 101. The second time we measured it was 104, so it's gone up. The third time, whoa, it's way back down to 104. The fourth time, it's down even lower, 100. And then the third time, it's way back up here again. Why is this better than each of those individual readings? What makes this better? What would you say about it? Okay, so again, now that I've explained that to you, pause the video and write down your answer. Why do we do it 5 times instead of just once? So suggest a reason. Student repeated investigation 5 times. Why would you do that? Pause the video. All right, well, the key thing here is that this number here is more trustworthy than any of these individual numbers. Okay, it's just a little bit more, and the key word here is reliable. We can rely that this is a more accurate reading because averages tend to be more accurate than any single reading. Okay, so obviously if we just did it once and we got 101, okay, oh sorry, if we did it once and we got 104, well, that's quite a lot higher than some of the other readings. Those ones are all much lower. Okay, 101, 101, 100. So is this really reliable, or is this maybe a little bit out there? Well, some would argue that this one is a little bit out there, the 104, because it's a good bit higher than some of the other readings. So it's not just quite as reliable as the average at the end. Okay, so suggest a reason. Averages are more ... Finish it off. What word did I say? Pause the video, write down your answer. Okay, hopefully you said averages are more reliable than individual measurements. Averages are more reliable than individual measurements. Right, we're at the end now. Okay, it says, does the data support the hypothesis that you wrote in part A? Explain your answer. Okay, so there's going to be two options here. It's either going to be yes, because, ... or it's going to be no, because, ... Okay, so it depends what you wrote up here. Here's your hypothesis. Did you say the more salt added, the higher the boiling point of water? Or did you say the more salt added, the lower the boiling point of the water? I don't know which one of them you thought was going to happen. But now that you look back and see what you thought was going to happen, remember this one here is 105. We worked that out here. Does the data support what you thought was going to happen? So what the data seems to show is that the more salt that's added, the higher the boiling point. The more salt added, the higher the boiling point. So if I wrote this hypothesis, then I would say, yes, it does. Okay. Yes, because as more salt is added, the boiling point increased or went up. Then you could say something like, this is what I said. This is what I predicted. Now, again, if you said no, well, then you could use the same thing. No, because as more salt is added, the boiling point increased. This is not what I predicted. Okay, so it just depends what you predicted earlier. So again, like I just said, this is an important type of question because it tests your knowledge on how to properly design an experiment. Do you understand what variables are? Do you understand what a hypothesis is? Do you understand what averages are? And do you know that when you get the data, how can you say whether it has supported your hypothesis or not? So this is a really important type of question that I think we could see a similar-ish one on your exam. So definitely something to pay attention to. All right, guys, we'll see you in the next video.